Hello 8th graders. In this IXL video we're going to be taking a look at assignment R2, and for assignment R2 it's called Pythagorean Theorem, find the missing leg length. And what's important about R2 is every one of these is going to be missing one of the legs. As you see on this problem, we know the longest side is 10 yards, we know one of the short sides is 6 yards, but we don't know one of the legs, one of the two short sides. And I'm going to jump over to my notes for a second here and show or highlight here quickly that when I knew the two short sides, a squared plus b squared equals c squared, was helpful. But now that I know the long side, c, and one of the legs, and I want to find the other leg, this formula right here, c squared minus a squared equals b squared, that is a lot better to find one of the legs. These equations are equivalent, they mean the same thing, but this version is easier to find the hypotenuse because c is all by itself. And this version is a lot easier to find one of the little legs because b is already isolated by itself. So in this video you're going to see me using c squared minus a squared equals b squared the whole time. Quite simply because every problem is going to be asking me to find a missing leg length. So for this problem, first thing I'm doing, in black here, we're going to go ahead and write out c squared minus a squared needs to be equal to b squared. Means the same thing as a squared plus b squared equals c squared. It's just easier to use to find the missing leg or the missing short sides. My first job, I see the big side, I'll go ahead and put a c right there in red. But the biggest side of this triangle is the 10 yards. That's going to be c, our hypotenuse. So that plugs into the c squared minus a squared equation, and I get 10 squared minus 6 squared, because that's where a is, 6. Is going to be equal to whatever b squared is. Just like the R1 assignment, your next step is now going to be, let me get my face out of the way here. Sorry about that. 10 squared minus 6 squared is going to leave us, we'll put that in blue here, with 100 minus 36. And then when I combine or subtract 36 from 100, that's going to leave me with 64, which is equal to b squared. And now we don't want to know what b squared was, we want to know what the original b is. And the final step, if you're not sure what number multiplied by itself makes 64, you can take the square root at that point. And the square root of 64, if you have a calculator, it would tell you the answer is 8. Later in this video, we'll show you how to take square roots on a calculator for some of the more difficult ones. That right there, using the c squared minus a squared equals b squared formula, is how we find a missing leg, and you can use this process for every single one of these, no matter what numbers they give you. We're going to show one more of the beginning ones, the first half of this assignment, but we're going to encourage you, as usual, we want you, now that we've shown one example, to pause this video and see, could you do this problem on your own before you watch me doing it? Now, hopefully you work this out on your own or put in some good effort, and I will point out as we're going to solve this problem together now that the biggest side here is 13, that's the c. So when I plug into my formula in the beginning, c squared is going to become 13 squared. And I'm going to take away a squared, which in this case was 12 squared. And that gives us 13 squared minus 12 squared has to be equal to b squared. My next step, which we'll show in blue, is just to simply do those exponents out. 13 times 13 is 169. 12 times 12 is 144. And so in blue here, you see we have 169 minus 144. At that point, you would combine or subtract the 144 from the 169. And in green here, that leaves us with 25, which is still equal, of course, to b squared. But this little side here couldn't be 25. That's way too big. B squared, b times b made 25. And you could take the square root at the end here or do some mental math and say, wait a minute, b must have been 5, because I know 5 times 5 is what would give us 25. So there's our final answer for this one, 5 feet. I could go put the 5 right here on b, 5 feet, just to kind of do some mental math, some common sense checking. Does this make sense? Yeah, 5 feet, 12 feet for the height there, almost or a little more than twice as big. That seems good when I look at that picture. this point, we believe we've given you everything you need on those couple examples to do the rest of R2. But as always, IXL makes some problems difficult, so if those of you who are getting into the 70s, 80s, we're getting stuck, we're going to show a couple problems now that are in the more difficult range for this assignment. But again, I would encourage you at this point, you got what you need. I'd maybe try to do some of this until you run into tricky ones that stump you, and then you could come back and watch the second half of this video. One way they make this math more difficult is by putting in big numbers, so we'll run through this example quickly. I'd encourage you to pause the video, try to do it on your own first before you watch me. But I would just, the biggest side here is C, or the 74, so my first job would be to plug in 74 squared for C, and 70 squared for A. And at this point, I would not want to be doing mental math with 74 times 74, so you're going to see me going to a calculator to do 74 times 74. Turns out it's 5,476. So I'm going to put that here in blue, 5,476. And you could use a calculator to do 70 times 70, but if I know that 7 times 7 is 49, and I know 70 times 70 must be 4,900 or 4,900. Now at this point we need 576. That would get us the difference between these two. You could use a calculator for sure to be doing that, and that's equal to b squared here. And then our last job would be to take the square root. The square root is always going to help you get rid of that exponent 2. The second power gets canceled out by the square root. So showing here in purple, taking the square root at the end. And if you know that 25 times 25 makes 625, I'm guessing 24 times 24, let's try to get that, is going to give us 576. So you could put square root of 576 into your calculator, and it would tell you, oh, 24 is the number squared that would make 576. And as you saw me kind of doing mental math there, if you knew 25 times 25 is 625, or get familiar with that, that's kind of how I had a good guess of 24 for the square root. But calculator is totally okay as you're getting more familiar with square roots. Plug in 24, there's our answer there. We're going to skip ahead into the challenge zone just to see that. So things start to get more difficult here. Basically by them putting in more difficult numbers, either numbers that are really large, or as you see in this case, sometimes they're going to give you numbers that are just decimals and a pain in the neck to work with. But we're still going to use the same formula. In this case, we're going to use c squared minus a squared equals b squared, because we don't know one of the short sides, one of the legs. And to be exact, they called it a, so you could also say c squared minus b squared equals a squared. That's what I'm going to use. They're both really the same thing. Now, at that point, I'm going to go ahead and plug in my numbers. 8.8 is the biggest side, that is C. So we're going to go ahead and label the 8.8 as C on our triangle and plug in that 8.8 into the equation. 8.8 is going to have to be squared. 4.3 is the B. That's also going to be squared and subtracted from the square of 8.8. And that will be equal to a squared. I'm going to use some calculators for this just because I don't know what 8.8 times 8.8 is off the top of my head, or 8.8 squared. It gives me 77.44. So write that in, and as you see, this is why we encourage you to have a whiteboard piece of paper with a bunch of steps. If you're using a calculator, you're going to need to be writing some stuff down still. I'll take 4.3 and square that, and 4.3 squared gives us 18.49, and so that needs to be subtracted. That 18.49 needs to be subtracted from 77.44. When we do 77.44 minus that number, we get 58.95. And sorry to be rushing this a little bit, the video's gone long. But that there is how we get the 58.95. That must be equal to a squared. Our last step here is going to be to take a square root from that, and that's going to tell us what a would need to be. And I definitely don't know that square root off the top of my head with that decimal, so I'm going to type in square root of 58.95. And they've told me, looks like I'm going to need to round my answer off. And I messed this whole video up. I'm sorry that last problem's a mess now. But when I take the square root of 58.95, I get a messed up irrational number, a decimal that keeps going. And you would need to round that decimal off. So I apologize. I'm going to go ahead and finish this problem even though I just broke the problem and you can't see it anymore. We would get 7.678. And if I need to round that off to the nearest tenth, quite simply I would look at the 6, which is right there. But after the 6 we have a 7. And so that tells me when I round the square root of 58.95 off, I'm going to call it 7.7 instead of 7.6. Specifically because that 67 is closer to 70 than it is to 60, so I need to round to 7.7 for my final answer there. So sorry that last example got a bit messed up there and I deleted or lost the problem. But as you see, if they're decimal numbers, you just need to write it out step by step using your calculator and then being able to estimate a round at the end. Thank you for watching to the end of the video. Good luck on the rest of R2.